I'm Chris Jones, and I'm the director of the Math and Climate Research Network. I'm based at the University of North Carolina at Chapel Hill, but it's a nationwide community that is a part of an NSF-funded project. The Math and Climate Research Network has been particularly successful in setting up a community of people which is vertically integrated, from undergraduates, graduate students, postdocs, faculty, all working together and getting to know each other even though they're not at the same institution, and having continuing and ongoing relationships, working relationships and collaboration. So I decided to work on climate issues because I felt compelled that this was just a tremendously important issue, that this is one of the major issues facing humanity right now. And the work is fundamentally mathematical in climate science. And so we needed to get more mathematicians involved in it, and we needed to figure out what the work to do was. And so for us to set up a network of people around the country was just a very natural form in which to realize this.
I think one of the biggest things that MCRN gave me the opportunity to do was to really expand my network and work with a very diverse group of people. I think one of the most valuable aspects of the Math Climate Research Network is that it isn't co-located. The fact that we have researchers all over the US and the world allows us to achieve critical mass in a particular subject area. So to have such a broad scope of scientists, we have to be spread out over the US so that we can have this network that allows us to speak to each other on a weekly and regular basis is extremely valuable towards moving research forward in all of those fields.
The Math and Climate Research Network has really defined my research program in the last years. It's guided me in how I choose problems. It's changed the way that I mentor students. One of the things that we've done over these years is put together what we call a focus group around the topic of tipping points, the mathematics of that, and also how it's relevant to climate. We meet over the web, and we have students who help organize this, and we can invite people from all over the world to both attend and to present. One thing we do that I think is novel, if you think of this as a seminar or a colloquium, is that we can have the person come back the following week for a question and answer period. It gives us a chance to really refine those questions.
We run an online focus group in which we study mathematical tipping points in climate and ecological systems. When I first heard about the Math and Climate Research Network, I was really eager to get involved with a group of people who were using math to solve problems that really seemed to matter. And so the Math and Climate Research Network and the problems that they were tackling seemed like a really exciting opportunity.
So I've been working with how software best practices can be brought into this environment and make software that's used by both graduate students and faculty better and more sustainable, and in particular reusable by other people if the results are really interesting. In the Math, Climate and Research Network, what we're going to do in the near future is actually have a mini session of implementing best practices for software and data management for problems that are relevant to graduate student and faculty research. We hope to see from this trial an improvement in the way people think about software, and essentially try to motivate a little bit of a culture change in science, in particular climate science, and have software be better produced, more accessible, and results be more easily reproducible over the long term.
We are particularly excited to be working on a next generation sea ice model with researchers at the Nansen Center in Bergen, Norway. Our role in this is to overlay this with a data assimilation scheme. This is research funded by the Office of Naval Research in the US and is particularly interesting to us from a mathematical point of view because the adaptive mesh that they use in the NextSim model challenges data assimilation in a fundamental way. This needs to be a much bigger part of applied mathematics. We need to have many, many more people concerned about climate issues, and it's something that we as mathematicians need to contribute to enormously. So my hope is that we will build on what we've already sort of figured out about how to create this community and create something and build something much, much bigger than we have right now. A recent initiative of MCRN is the publication of a new journal. It is an open access journal and it is dedicated to the publishing of papers that fall between, on the one hand, math and stat, and on the other hand, climate science. We have our first issue out and we are eagerly anticipating further submissions to the journal as the years go on.